Hello, in this video we'll be continuing our multivariable calculus series. So in the previous video in this series, I taught you how to differentiate, I told you what a partial derivative was and I gave you some questions to differentiate. In the last video, my laptop went like it was glitching out a lot and I left the last question as like a homework problem. So this was the last question. So if you were given h equals natural log of t squared plus tu, and you are asked to find the partial derivative of h with respect to t and the partial derivative of h with respect to u. Okay, so obviously you had to go at those problems, hopefully. First off, let's just go straight back. So let's do partial derivative with respect to t. So delta h, delta t. Differentiate this entire thing with respect to t. So a partial derivative means you treat the other variable as a constant. So our u is treated as a constant in this case. So as you can see, this is a chain rule. So you've got to differentiate the inside and then the outside. So if you diff the inside, you get t squared plus u multiplied. When you differentiate a log, so if you have the derivative of if you have the derivative of log of x, that is equal to 1 over x, okay? So this whole thing is just going to be multiplied by 1 over t squared plus tu. So you're going to have delta h over delta t is equal to 2t plus u all over t squared plus tu, okay? Now for the second part, so that's that one done. Second part, partial derivative of h with respect to u. Differentiate this entire thing with respect to u and just treat t as a constant. So you're going to have to do chain rule again. So differentiating the inside, you're going to have t, because t squared is going to be gone because it's treated as a constant. Multiply by differentiating the log, it's 1 over t squared plus tu. And then we're left with partial derivative of respect to u is t over t squared plus tu. Alright, so that was the answer to the last question in the last video on multivariable calc. I'm just going to rub that out now. This video is going to be, it's like a step up pretty much. So you know how to differentiate now. We're going to start looking at second derivatives. So recall, if we have a function of two variables, if we have, let's say, u of x and y gives us some z value, you can differentiate that with respect to x, and then you can differentiate that with respect to y and treat the other variable as constant. You can also do the second derivative of both the respective variables, okay? So you can have the second derivative with respect to y. You can also have these things called mixed second partial derivatives. So what do I mean by that? I'm meaning you can get this function here, you can differentiate with respect to x, and then you can differentiate the whole thing again with respect to y. So you're left with the second derivative diffed with x first and then diffed with y. Same with that, you can also diff it with y first and then diff it with x. Okay? So you can have the squared over dy dx. So if you have a function with two inputs, it gives one output, you can get two first derivatives, but you can get 4 second partial derivatives, because you can get two with the same variable, and then you can have two with mixed. Okay. Now these aren't necessarily the same, but for common functions they are, but they're not always the same. Okay. So you need to differentiate. You need to do both of them. Okay. So let's just get straight into some examples of second differentiation of partial. Let's get into second derivatives of multivariable functions. So let's just start with question 1. All right. So question 1, f is equal to x to the power of 4 divided by a y squared. You're going to find the second partial derivative with respect to x and the second partial derivatives with respect to y. That's a mouthful, holy dooly. Alright, so there's no mixed second partial derivatives, so you're just going to differentiate both of them twice with respect to x and both of them twice with respect to y. So feel free to have a go at that and then I'll start solving. Alright, so let's just do x first. So differentiating it with respect to x first. So just going to differentiate the whole thing with respect to x. Going to treat y as a constant. So we're going to have our first derivative is going to be 4x to the 3 over y squared. I'm going to change how this looks now. I'm going to just bring the y squared next to it and just have it y to the negative 2. You'll see why I'll do that in a sec. Actually, no, I'll just leave it. Actually, no, I don't need to do that because I'm not having any mixed derivatives. Just leave the y squared on the bottom. Now I'm going to differentiate this again with respect to x. Okay, second partial derivative. Differentiate the whole thing with respect to x. 4x cubed y squared. To do that, it's just going to be power rule. So you're just going to bring the 3 down the front. So you're going to have 12x squared over y squared. Boom, that's the first one done. Alright? If it let me select it. Cool, let's put that in the corner. Alright, let's do so we've done that one, let's do this one now. So differentiate the whole thing with respect to y. So then I'm going to treat x as a constant. Now I'm going to change how it looks on the brackets. So we can rewrite this whole thing here as x to the 4 multiplied by y to the negative 2 because of our index laws. So differentiating this whole thing with respect to y, x is a constant, so negative 2 comes down the front, and subtract by 1, so you get negative 3. Alright, I'm going to leave it like this. I'm not going to simplify it yet because we've got to differentiate it again. So second derivative, I'm going to diff this entire thing again with respect to y. Treat x as a constant, so the second derivative with respect to y. I'm going to bring the negative 3 down the front, multiply that by negative 2, so I'm going to get 6. X to the 4, multiply y minus 1, so you're going to have negative 4. Now I can simplify that, so it's just going to be divided by y to the 4. Alright, cool. That's the working for question 1. If you have any questions at all, please leave some in the comments and I will try my best to answer them. So there was no mixed derivatives in there. There will be some in the last 2 questions of this video, as you can see, but for now there isn't. Alright, let's have a go at question 2. So if you want to have a go at question 2 without me, feel free to have a go, and then I'll start solving it. Alright, so we got, instead of x and y, traditional letters, we've got w, t, and u, which are still pretty traditional. T is used as a parameter, and u is pretty useful. See what I did there? Alright, so I'm going to differentiate the whole thing with respect to t. So differentiate w whole thing with respect to t. Sorry, my pen's not working that well. So once you write down the letter you're differentiating, you're ignoring the other letter and you're just treating the whole thing as a constant. So this is going to simplify down to just the 2 come down the front and subtracting by 1 in the power. So you're going to have 2t sine u. Okay, are we done? No, not quite. So we found the first derivative, that's nice, but we're after the second derivative. That's the whole point of this video. So differentiating again, you're going to have the second derivative. Differentiate the entire thing with respect to t, 2t sine u. Treat this whole thing as a constant, okay? Differentiating 2t, that just turns to 2. So this whole thing here is going to be, it's going to be just 2 sine u. 2 sine u. Okay. Boom. That is the first half of the question done. So we found the second partial derivative with respect to t. Okay, so that one's done. Let's take a look at this one. Alright, so we're going to differentiate the whole thing with respect to u. So t is our constant now. So differentiating this whole thing. So u, differentiate the entire thing with respect to u, t squared sine of u. Treat the t squared as a constant because it is, because it's taking the partial derivative. Differentiating sine, that turns to cosine, so it's just cos, so t squared cos of u. Okay, now we've got to diff this again, so the second derivative with respect to u, if my pen works, so you can have delta squared over delta u squared, differentiate the entire thing with respect to u. T squared still a constant, so when you differentiate cos, that turns to negative sine, so the whole thing's going to be negative t squared, if my pen is working, sorry guys, negative t squared sine of u. Boom. That's both of them done. Have any questions, leave some in the comments and I'll try my best to answer them. Now, question 3 and 4. I've only included 4 questions in this video because doing the second partial derivatives of functions, it's a lot of work. And honestly, you could skip the whole first video and get straight to this one if you already knew how to do it, and you'd still get enough practice in, because there's a lot of meat and a lot of thinking. So now we're going to do some mixed second partial derivatives. These ones take a lot more thinking. Alright? Because you differentiate one with respect to the other and treat the other as a constant, but when you diff it again, you got to switch which one's the constant. So have a go at 3 if you're feeling brave, and then I'll start solving it. Alright, so we're going to do the first one here. So we're going to differentiate the entire thing with respect to y first. So this is the first one I'm differentiating with. So delta z, delta y, differentiate the entire thing with respect to y. So our x to the 8 is a constant. So I bring the 4 down the front from the y. So delta z over delta y is going to be x to the 8 multiplied by y. 4 minus 1 is 3. That's the first derivative. Differentiating this now, this whole thing with x, so you can have delta squared over z, delta y, delta x. Now you can differentiate this entire thing with respect to x. So now y is our constant because we're differentiating with respect to x. I'm just going to make this a bit smaller because it's a bit chunky. Move that there. So we're going to have delta squared z over delta y, delta x. Differentiating the whole thing with respect to x, so the 8 comes down the front. 8, x to the 7, y to the 3. Boom! First one done. Now, it was the tricky part was this step here. So in these first steps here, I ignored my x and treated it as a constant, but when I got down to here, my x wasn't my constant anymore, it was a variable. Okay, because it's a mixed second partial derivative. Okay. Alright, let's have a go at this one. So you're going to differentiate the whole thing with respect to x because the x comes first here. Alright, so delta z, delta x, differentiate the entire thing with respect to x. Okay, so this entire thing. Alright, so the 8 comes down the front. 8 divided by 4 is 2. So delta z over delta x is going to be 2x to the 7, y to the 4. Now I'm going to differentiate the whole thing with respect to y. So delta squared z, the partial derivative of x, partial derivative of y, differentiate the whole thing with respect to y. Now my x is a constant, so differentiating. Bring the 4 down the front, subtract the 4 by 1, so we're left with 8x to the 7, y to the 3. Now you're probably wondering, why did we need to do that if they're exactly the same? Well, sometimes they're not always the same. For common functions, they are the same, but they're not always the same. And I like you to have a go at both of them because it gets used to your skills and you're actually thinking of the question. Because with this question here, you had to think, all right, which one's going first? And this one was, which one's going first, okay? So you did it in different orders. That's why I want you to do them. And they won't always be the same like they are here. Sometimes they won't be. Okay, so let's have a go at question 4 now. Let's get some more room for 4, because 4 is going to take a bit. Alright, so if you want to have a go at question 4, feel free to have a go at question 4 without me, and then I'll start solving it. Alright, so this one, same thing, mixed derivatives. Let's do this one first. So differentiate the whole thing with respect to y. So delta z over delta y. Differentiate the whole thing with respect to y. E x to the y. Alright, so x is our constant. Recall, if we're differentiating an Euler, it stays the same. But if you have a constant up here, the constant comes down the front, and the constant stays up there. Okay? So recall that. X is our constant. So we bring the constant down the front, so our x comes here, and then you have e x to the y. Alright? Are we done? No, we're not. We've done the first bit. You have to think about that for a bit. It's a chain. We did a little chain rule, basic chain rule. Now we're going to differentiate this whole thing with respect to x. So delta squared z over delta y delta x. And then you differentiate this entire thing with respect to x. Okay. So if we're differentiating this whole thing with respect to x and y is a constant, that's a product rule. So a product rule is you diff it, leave it, diff it. I think that's what it is. Diff it, leave it, plus leave it, diff it. Yep, that's it. So differentiate that, leave that, plus this again, leave that, and then differentiate that. Okay? So I hope you know how to do product rule. So I'm just going to rewrite down here because I'm running out of room there. So I'm just going to rewrite delta squared z. Oh no, is my laptop lagging now? I really hope it isn't. I might just write it here. Delta squared, delta z over delta y, delta x. So diffing the x is just a 1, so we're going to have e x to the y, plus x stays there. Now we're going to differentiate this bit here. Differentiating that with respect to x. You bring the constant down the front, so we're going to have a y here. And then you have e x to the y. Alright, cool. So that's the first one done. Boom. Alright, let's make that a bit smaller, because I'm going to write on the... Could just move that down there. Alright, cool. Let's do the second one now. So originally you're going to have to differentiate this whole thing now with respect to x instead of y. So differentiating this whole thing with respect to x. E to xy. Treat y as a constant, so dz over dx is going to be equal to y e to xy. Alright, differentiating this whole thing now with respect to y, dx, dy. Going to have to do another product. That's error. That's meant to be a y. E x to the y. Product rule again, so you're going to have to write this out again. Differentiating the first bit, you're going to be left with just 1 multiplied by e x to the y plus y. Differentiating this bit here, you're going to bring the x down the front, so you can have multiplied by x e to x y. Boom. Done. Forgot a little oh, there's no square there. Alright, cool. That one's done. Alright, if you have any questions about this video or anything, please leave some in the comments. In the next video, we'll be going over the chain rule with multivariable calculus, which is a bit complicated as well. But if you could do this, I think you can handle that. Alright, if you have any questions, leave some in the comments. Thank you for watching. Subscribe.